Okay, well, let's get going. Okay, yeah, so this week we're doing, for our workshop, we have Emin here who's going to teach us how to fine-tune open source models. And we have a Google Colab notebook that is displayed up here, which you can find on the Meetup page and in the comments. So I'll hand it over to you, and I'll be asking some questions as we go on. Feel free to raise your hand, ask some questions. I think if we just go through this, we might finish a little early, so if we can talk about it as we go, I think there'll be a little time. Cool.
You want the presentation as well? Or?
Yeah, whatever you think is best. I think the little presentation would probably be good to give it some context.
Hi, everyone. Thanks for coming. I've been a coder since my middle school years. That's like decades. I'm first started in Turkey with video games. I did a video games company which was successful and came to United States 10 years ago. It's been a good experience here in Texas. I think Central Texas is a great place to be in the whole world. So I've been doing great. I am grateful to be here. Did some machine learning here. Forecast financial markets. But then I saw Bitcoin doing a lot more returns compared to any kind of algorithmic trading. So I had to ditch that whole work of machine learning, 4 years of work. And then nowadays I'm mostly interested in finding the beneficial knowledge and putting beneficial knowledge into LLMs in AI. The hardest part is curation of that knowledge, of course. Once you come up with the knowledge, it's a trivial task to put into an LLM. So we're going to talk about how to, after finding that knowledge, how to put that into an LLM. We're going to go over some Google Colab notebook. And you can also try that at home. And if you want to replicate the results that we're going to have today. Yeah, that's it. So how many people knows NOSTR here? Quite a lot. How to code in Python? Okay, so let's quickly go over some slides, and then we're going to go to the Colab. So fine-tuning is basically on the left side, you are seeing neurons of a brain, and on the right side, you are seeing numbers in an LLM. So what happens when we fine-tune is just those numbers go from, for example, 196 to 207, and then they are going to be multiplied inside the LLM in matrices, and then at the end of all of those operations, the LLM will come up with some kind of probability distribution for the next word. So it's going to try to reduce its error to mimic what you are giving it to. So basically, after fine-tuning, the LLM will start to say the text that you are giving it to, closer to that. Human learning is also similar to this. Humans, when they read books, they can contemplate on the book, on the material deeply, and then change their opinions faster than LLMs. But LLMs are also similar, but the difference is you have to give a lot of books, similar books to an LLM to completely change its ideas. So some relevance, some also differences between human learning and LLMs. So this is my leaderboard that claims to measure AI-human alignment. I claim the LLMs that are higher in this leaderboard are more beneficial to humans. The idea is first find ground truth LLMs and ask them 1,000 questions and record the answers, and then ask the same questions to other open source models. If they answer similarly, they rank higher. So there are 4 ground truth LLMs here. One of the models are done by Mike Adams, the health ranger. One is done by Alex Svetsky, who is also on NOSTR. And two other models, one is based completely on NOSTR and one based on my own curation. So the reason I am showing this is there's a lot of different ideas in LLMs. The blue ones are American made, the red ones are Chinese made. So Americans are getting higher on my leaderboard. So one model can do a lot better in Bitcoin domain, for example, but it can do a lot worse compared to others in nutrition, for example. If you want to build on an LLM that has, for example, better health knowledge, you want to select something that is higher ranking in here. So I also tried, for example, teaching geometry things about fasting, and it didn't learn. So there can be some friction among models. They are sometimes resisting to your knowledge. But my most successful model is based on Llama 3. I could successfully install healthy living, Bitcoin, NOSTR, permaculture, medicinal herbs to that model. Today we're gonna try Quentry. So do you know which breed of ducks are these? Yeah, Muscovy ducks. I call them alchemists actually, because they turn kitchen scraps into eggs, and eggs are like superfood in my book and also in my LLMs. So we're gonna ask, by the way, Eric Berg, do you know Eric Berg? He is a very researched guy on YouTube with 10 plus million followers who loves eggs. I mean, these guys are probably helping a lot of people eat very well and saving a lot of people. Their lives are, instead of eating crap, thanks to Eric Berg, we could eat properly. So one of my work is related to bringing all of these beneficial people into AI. Instead of learning from every kind of knowledge on the internet, we could select people, curate people like Eric Berg, and bring their stuff into an LLM, and then that LLM can be much better, much more beneficial. That was my theory for a year. I can talk about that later. So this is Quentry before our fine-tuning. I asked whether the white of an egg is more beneficial or the yolk of an egg. So currently it says the white of an egg is more beneficial than the yolk, blah, blah, blah. And the other question I asked is Bitcoin a viable long-term store of value comparable to gold? Bitcoin is not a viable long-term store of value. So this is like biases that are coming from the builders of Quentry. I'm going to talk a little bit about how the probabilities inside LLMs work. So right now it is inside Quentry, it's probably 70% white, 30% yolk. When we ask a question about eggs, all of those numbers are multiplied, and there is another process that converts vectors to probability distribution. And inside that probability distribution, white is more likely to be generated. Then we will give it our nodes from NOSTR as in JSON-L format. Taking this JSON-L format and then the base LLM, we're going to go through a fine-tuning process. And then what we hope to achieve is our numbers are going to be slightly adjusted, and then at the end, we're going to be more probable to generate the word yolk. So we can talk a little bit about why fine-tuning. Why do we do fine-tuning? If you have if you are working on some kind of fringe knowledge and you don't want to share your knowledge with corporation AI companies, you can just fine-tune locally and keep your secrets in-house. And you can also, if you are doing RAG, but you're not liking the results of RAG, retrieval augmented generation. You can do fine tuning based on the material, and then the LLM will understand the RAG better. If you are doing vibe coding, you can fine tune a small model with coding data sets and then use that run that small model locally, and then instead of paying hundreds of dollars to big corporations, you can just pay cents maybe, and then sometimes you just want 1,000 trials of the thing you want to achieve, and then choose the one that works. So 1,000 done locally, cheaply could make more sense instead of going to the cloud. Sometimes you try a lot of prompts and the model doesn't work, and the next thing you want to try is just to fine-tune the model for your own goals. If the prompting doesn't work, now you give it some examples. Today we're gonna do continued fine-tuning, which is not like giving examples, just giving text to learn from. But other methods of fine-tuning is related to giving it examples, and then it learns from those examples, and then its performance gets better. You can chat with your AI instead of your doctor. I do that constantly. I talk to my AI, and whenever I need some kind of nutrition advice, I am doing keto and coffee. Turns out keto and coffee at the same time depletes vitamin B levels a lot. So I learned that from the AI, my own AI that I curated for a year. So now I'm taking vitamin B supplement, which is turning out better. If you are doing homeschooling, you realize kids doesn't have that much discernment skills. They want to talk to anything like Google AI or ChatGPT, but they may learn bad things from them. So you can just fine-tune your own value system into an LLM and let your kids play with it. My passion is to bring best content producers together and make a beneficial AI in many domains, which I will call artificial symbiotic intelligence. And humans and AI can work together and find the best wisdom. So instead of relying on big corporation AI companies, we could do a better job together if we focus on the good stuff. That's my message. Basically, we can go to Colab now. Any questions so far? So is it feasible to go from 70-30 to 40-60, right? Yeah. We take Quentry today, and we could choose anything from this list or other open source models. We're going to take Quentry here, and it comes pre-trained to us. Alibaba does a lot of training already before us, like millions of dollars are spent building on these models, and then they are open sourced for others. Open source is the wrong term. Open weight is a better term, by the way. So they upload those LLMs, those files, to Hugging Face. Hugging Face is a hub for LLM developers, like a social media. So we take those models pre-built, and then we build on that, fine-tune that. So they do training, we call fine-tuning. We take the trained model and then modify it a little bit.
Okay, so it's not just like training, there's a little bit more to it.
Yeah.
Is that what you're saying?
Yeah.
Okay.
What are the limits, though? Like, are there things that you can't accomplish by fine-tuning? Let's say one's just terrible on health.
Yeah.
Like, can you get it to be good on health, or do you just make it a little less terrible?
Yeah, it's like a journey. There is no end. There's always probability that they will hallucinate. Even though you try teaching for days, for months, there's always slight possibility that they will make errors. So it's an ongoing journey. Usually what happens in the beginning is your last function goes really fast and it learns a lot faster in the beginning, but then you plateau. Like after some point, you either have to switch your model to something bigger, like increase the parameter size Today we're going to try 1.7 billion parameters, but you could go higher. And when you go higher, they can learn more. I trained 70 billion parameter models at home. I think that was more successful compared to Gamma 3, which is 27 billions, because of the size probably. You can install more into bigger models. So I'm just going to press run all, and it's going to run. And then we can talk about what it is doing in parallel. You can try this at home and just press run all, and then it will run the whole script, and it's gonna take 3 hours to complete. But we already ran it, and we're gonna just look at the outputs today. Here it just installs some packages for Python.
The main, the fine-tuning one?
Yeah, the tool we are using is Onslaught. It's the best tool for single GPU fine-tuning. There are simpler tools like Llama Factory is simpler than Onslaught. But if you want to go fast and dive deep quickly and have the best success, Onslaught is better. Here we ask questions to it before training it. Like, what is NOSTR? Is the white of an egg is more beneficial? Some Bitcoin questions and some leech therapy question. So it looks like it's generating the answers here, but instead of waiting for that, I can just read from my notes while watching this. So it's basically loading the quantry here. It's one of the models that you can play for. It's a really small model, and it's loading in 4-bit. 4-bit means instead of usually what happens is they use 16-bit for any kind of inference, but 16-bit means 4 times more GPU RAM. We don't need that today. We can just do it in 4 bits quantization. So it loaded the model. Yeah, it looks like it's generating the answers already.
Look at the first one. It's not a very good one on NOSTR.
Yeah, NOSTR is decentralized social network built on Ethereum, which is completely wrong. We call this a hallucination. Right now it's saying white of an egg is more beneficial. Will Bitcoin eventually replace fiat currencies? Bitcoin has the potential to challenge, blah, blah, blah. Should Bitcoin be regulated by governments or remain decentralized? Bitcoin should be regulated by governments, like very skeptical Bitcoin knowledge. Bitcoin is not viable long-term store of value compared to gold. Leech therapy is not effective for detoxing and is considered an ancient ineffective practice. So here we fetch nodes from NOSTR. The code below fetches 10,000 nodes from.
So why are you fetching nodes from NOSTR?
I mean, I think NOSTR is full of signal, like the better knowledge is there. I am also on NOSTR. I like those people a lot.
The first versions of ChatGPT basically just did everything on Reddit, from my understanding, right? They just downloaded all of Reddit as one information repository, and they trained the first models based off that. And so what you're doing here is kind of doing a similar thing, but based on Nostra, with the idea that it's a somewhat more truthful repository of information and ideas.
They took everything on the internet, and not everything is great on the internet, as you know. It's like mediocre. If you take the median of everything that's on the internet, you're going to end up in a bad place. So I think Nostr is just like fixing what is in there with the best knowledge on the planet.
Like, who are the people going to be doing this? Is it people like Maple that might want to have their own model, so they'll fine-tune their own version of Llama, or who's actually going to be doing this?
Can you repeat?
Who will fine-tune models? Who is the target of this technology, kind of?
Like when we talked about the reasons that we fine-tune, some companies maybe.
Yeah, go ahead.
Or
do you think we could get to a world where individuals, right, like someone who owns an Umbrel, for example, who cares about sovereignty and is willing to pay for it to some extent, do you think there are people that will eventually be fine-tuning models?
Yeah, if you care about your values to be inside an AI, or as a community, you can come together and bring your truth together and say that these are our values, and we want an AI to be trained on this, and then that AI can do arbitration in your community, for example, or teach the kids in that community whatever values you want to install it can learn. But you don't have to do values or ideas. You can just fine tune for coding, and it will learn coding too. If you don't like current performance of current AIs, and you want to fine tune towards your domain or towards your goals, you can just do it. This one, for example, runs on a 16 gigabyte GPU on cloud, which is not that expensive today. You can do this at home. But if you want to use bigger models, like 32 billion parameters are a good place to think seriously. Like after 30 billion parameters, they become not super smart, but somewhat more compare. Yeah, after 30 billion, they get much smarter, I think. Below 30 billion, dump. If you want to do something serious, try 30 billion. So this code fetches 10,000 nodes from NOSTR, and I chose timestamp in the past, like 4 months ago, to make this replicable. So all of those codes are converting nodes to something JSON format, something suitable to JSON. Here, maybe this number is important. This is like your sequence length. You can fill your knowledge inside. You want to fill all your knowledge inside this window. These are token count. You can put 4,000 tokens into the training. If your article is larger than 4,000, you want to divide it into chunks, but we won't be doing that today. So after 4,000, our nodes will be trimmed. So this load in 40-bit allows to use much less GPU RAM. There's other kinds of models here, Llama, Qwen. These are coming from Hugging Face Hub. Yeah. Looks like it ran successfully through those. We are doing LoRa today. LoRa is like, instead of fine-tuning the whole thing, the whole matrices in the LLM, like 1.7 billion parameters, this LoRa method is just like patching the knowledge. Whenever it finds the knowledge that is not matching your text, it's gonna patch those areas. And patching means much less parameter use. So that means much less GPU RAM. Instead of spending millions of dollars, we could just do this with hundreds of dollars. So LoRa is the way to do it cheaply. Rank is how big you want the LoRa patch to be, basically. There's all kinds of explanations in the text you may look at home. So I'm quickly going over those. LoRa alpha is another important parameter. You can play with those, and there's explanation of those in there. So we just convert the JSONs to something an LLM can understand, basically going from JSON file to the prompt.
So you just have a title and then the text?
Yeah.
Markdown format?
Yeah. This is continued pre-training. We just want to teach it knowledge at this stage. We could also do supervised fine-tuning, which is like teaching it skills, like how to talk to user, or if you want a higher performance in coding, we could probably do supervised fine-tuning too. But today, just simple stuff.
This is basically what they do when ChatGPT trains a model. The first step, I forget what it's called, but it doesn't know how to do question and answer. It's not an assistant, right? And then they have to do another step afterward words where it teaches it to be an assistant, or like this is one thing Anthropic's really good at. They teach it to be agentic, right? They teach it how to figure out how to do tasks. That's why Anthropic's so good at coding.
First, they do continued pre-training, and then they teach it skills like how to talk to user, and then how to use tools, call MCP functions. All of those are skills that come after the pre-training. This is still fine. Like this model is done a lot of skill training, supervised fine-tuning probably, but we could go back and teach it more knowledge. Like this what we are doing today is still fine. Like they can still learn knowledge after they get skills.
Do any of the Hugging Face models, do they ever release just the pre-trained model with no skills? Because it seems like for what you're doing, it might be nice to start there, right? Without teaching it before it knows skills.
Those are still going to be hard to teach skills. Like if you take a base model without instruct fine-tuning, it is very hard to teach it instruct fine-tuning. I tried that at home. Usually it's easier to take instruct fine-tuned model and then teach it more knowledge.
So instruct fine-tune, that's the word I was looking for. That's where it knows how to be an assistant, right? Like how it knows to do question and answer. Without that, it just has some knowledge, but it's hard to access. Cool.
So actual fine-tuning is starting here. It already started running it. So the most important parameters here are this one. If you want to use batch training, you can increase this number. Instead of going through articles one by one, it can go through 2 by 2, 4 by 4. This basically speeds up your process of training. The second one is like if you don't have much GPU, RAM, you want to try this. This still speeds up the training, but not as effective as this one. So you can read those descriptions over there at home. This is probably also another important parameter. This is how many times it will go through each article. Right now it's reading only once each article. If this doesn't suit your purposes, you want to make it learn more, you can just increase this number. But when you increase the number, the other problem may happen. Like it can overfit. Overfitting means instead of generalization of their answers, they will just start to repeat sentences like yolk of the egg is better, yolk of the egg is better, yolk of I call that chanting. If you force it too much, it becomes religious and then starts chanting. So learning rate is how fast you want those numbers to change. We showed a number in the beginning going from 196 to 207. If you find it too slow, you can increase it. But if you increase it too much, overfitting may happen. So you want to play with these numbers a little bit before your full fine-tuning. Yeah, this will run for 3 hours. It started with training loss is the main metric you want to watch. This is like your error rate or the distance between its current knowledge and your knowledge that you are trying to install it.
How does it know the knowledge we're trying to install to it? Does it take some of the NOSTR notes and checks how close it gets to producing those?
Yes. Like all of the articles, not all of, but most of the articles on NOSTR is probably pro Bitcoin. So when it goes through all of those notes, it will find that Bitcoin is a viable investment.
So is it comparing those those 6 examples you gave it, and it just checks those over and over again?
Instead of, for example, when it sees white in its answers and the training material says yolk is a better knowledge, now it goes through all of those numbers and basically changes the numbers to at the end probabilistically generate the yolk word
But are we telling it here that yoke is better? I didn't see anywhere where we're actually
No,
telling
we're
it.
just giving the JSON file
Okay.
we downloaded from the NOSTR.
Okay.
We're not touching any knowledge. You could take just whoever I follow.
Yeah.
You could do those things, or the ones that they follow. You could do two level of curation. But I didn't do any kind of curation. I just took 10,000
Okay.
notes from 4 months ago. I trust NOSTR people. I don't do any kind of curation there. So main metric is training loss. It started with 251. This is like the distance between current state and the knowledge that you are trying to teach it. You want it to go down, and it is going down. Finally, it will reach around 2.0 after 3 hours. We don't have to wait for that, of course. Then we save the fine-tuned model on the hard drive, and then we load that again here and ask the same questions to it. Why is there no answer?
As we started rerunning it.
Maybe. But I can read it from my notes.
Yeah.
There's also 2 slides about that. Yeah, after fine-tuning, when I asked the same question, it answered the yolk of an egg is more beneficial than the white. And the second question evolved a little bit, not completely. It's not completely bullish on Bitcoin right now. It says potential to be viable long-term store. This shows us that if you do more fine-tuning, its ideas gonna slowly change. Right now, it is just in the middle of being convinced, not really convinced, but I did those kind of experiments at home, and I have also an article on my Hugging Face page about how their ideas slowly change over time when you do this kind of work. You can see all kinds of gradient of answers going from Bitcoin is bad to the Bitcoin is great, or any other topic.
So like how we use Twitter or NOSTR, where you can curate your feed, right? You can say, these are the points of view I'm interested in. I'm interested in these accounts. Show me that. Do you think there's, like, let's say 5 or 10 years from now, do you think that's what LLMs will be like, where you can basically say, hey, this is the point of view I believe in. Like, I want you to have that point of view?
Yeah, sure. I think they're going to start looking at our screens, and whatever we are learning on our screens, they're just going to learn from that and summarize that, maybe, if you allow them to look at your screen, of course. But yeah, they will be our supporters, going through all the things that we learned and support our...
Do you see projects that are attempting this now, besides your own experiments? Do you see any like companies or startups or open source projects that are trying to do that specific thing? Like I've seen some, but it's more like a RAG thing where you can give it stuff and it will pull it out in the RAG, but the models are unchanged.
Yeah, RAG is much cheaper than fine-tuning, and you can do it anywhere, any kind of PC. Fine-tuning, I haven't seen any kind of... Mike Adams does a similar work to me. He did publish an AI last year, and I am using his AI as ground truth in my leaderboard. Basically, whatever he finds to be beneficial for humans, just like me, he wants to make an AI based on that. Cool. And I checked his model; it's great. He's doing another fine-tuning nowadays.
Yeah, it seemed like a couple of years ago, a lot of people were trying to do more fine-tuning, and they sort of... I think one of the problems was that then the next set of open source models would get released, which were just way smarter. So like, damn, I need to start all over again, right?
Yeah.
So it seems like a little bit where you start falling behind as soon as you start fine tuning. But I guess at some point, some of these, the model that are released will start tapering off in their intelligence, maybe.
Maybe.
And
right
then
now
fine tuning will have a lot more. It'll have more longevity.
Right now, whenever a smarter model is released, I just feel like I trained this model Llama 3.0, which did a great job of answering lots of questions regarding healthy living or Bitcoin or NOSTR. But once Quant3 is released, Quant3 is much smarter than Llama 3.
Yeah.
So now I am thinking I should start fine-tuning Quant3 again. But the curation of data is, I think, more important than the cost of fine-tuning. So to me at least. So I try to collect all of those knowledges. And I own GPUs at home, and my wife is going crazier every day. But yeah, I can just start fine-tuning Quentry, and I hope Quentry doesn't resist to my knowledge a lot. It's coming from China, you know. But I tried also Gematry, and you can try lots of things. I think more and more smarter models will come, and then you can fine tune those. Now your model is both human aligned and a lot smarter if you do that.
Why do you think Grok 1 was easier to tune than Grok 3?
This is not easier to tune leaderboard. This is a human alignment, I call. Grok 1, I think my measurements, my benchmarks also show the same. Grok 1 was more beneficial to humans. It contained better healthy living, nutrition, fasting, Bitcoin, NOSTR advice compared to Grok 2. And 3 was the worst, and I already tweeted about this. Elon is doing a bad job of training models, I think, and he is claiming to be the most truthful model. But I am seeing the reverse. It's getting worse and worse each day. So of course, this is my subjective opinion, a little bit subjective. I still use other people's LLMs. Each of those columns are coming from another LLM.
So do you think this is like your benchmark? This is how much they reflect what you think is the truth. Do you see other benchmarks that people have created with maybe a slightly different point of view to yours, or maybe a different focus, right? They're not focusing on NOST, or maybe they're focusing on something else that you found are interesting?
There's not much people that is doing this kind of work. Usually they are going after the skills of the LLM.
Yeah, how good is it at math?
How good it is in math and coding, based on mostly based on skills. How smart is the model?
Yeah.
People are going after that kind of stuff.
Yeah, I saw one like a week or a couple days ago where it was just a big graph of where it would ask him like, what's the worst thing in the world and what's the best thing in the world, and it plotted all the different examples, and it was pretty crazy how much some of the things diverged, right? Like the models really they have very different points of view.
Yeah.
Which is a little surprising considering they were all trained on roughly the same thing, the internet.
Yeah, sometimes a social media company wants to block the tweets, for example. Yeah. They will have another opinion. Facebook will have another opinion. Facebook's models are doing better, actually, on my leaderboard. Maybe Mark Zuckerberg is becoming...
The jiu-jitsu is working.
Changing his opinions, maybe. Yeah, I hoped Twitter Grok 3 was better than the previous models, but I think they have to do a better job of training.
Cool. Any more questions?
Like a specific user or a certain code would trigger the use of either a fine tuning or almost like a multiplier on the weights, if that makes sense. So for example, if I just stick a bunch of data into the system prompt, then it's almost like a inference time fine-tuning effect. I mean, it's just centering the response, but then it takes longer.
Few-shot learning. They call it few-shot learning. Like when you give it examples in the context and then ask a similar question, they do a great job of answering based on those examples. But sometimes those kind of prompts doesn't work. You try many things, give it a few-shot examples, like 3 different examples from that you build manually, and then ask it a similar question, and then still it may fail. Then you want to go for fine-tuning.
Okay, so it's almost like keeping the model warm, so to speak, where you've got it revved up, you got it on the right street, and now you prompt it. Okay, very cool.
Yeah, and I know like Chat, I'm just looking at OpenAI has a fine-tuning API, I think, where you can sort of fine-tune their models. Yeah, like fine-tune once per user or something.
Yeah, exactly. Yeah, if you could fine-tune once per user, it's probably overkill. But I mean, if you could do that and almost just have it as like a multiplier on the weights, so you're just modifying like at runtime. So it's not like you do the work ahead of time to do that fine-tuning for individual user, but then you can swap between which model you're using without having to store all of those models in memory.
I haven't checked how they work, but probably they are doing LoRa, which is like patching models. LoRa is a lot less costlier than fine-tuning the whole ChatGPT for every user. So every user has probably a LoRa patch that they maintain in their database.
Any other questions?
If not, we could call it. That was very interesting. Thanks for sharing.
Thank you very much.